Okay, so number 42 says, how can we rewrite it? Do you think that every subtraction problem can be rewritten as an addition problem that gives the same result? Do you think that we can rewrite every subtraction problem as an addition problem and it has the same value? So on this, I want to be really clear. Let's look at what we've done so far. So on here we have where we were subtracting and then we were adding. Same value. On this one here, it was -4. On this one here, we have subtraction, and then we have adding, and we ended up with +2 for both of those. This one we have subtraction, and then addition, where we ended up with +9. So what do you think? So in this case, every subtraction problem can be rewritten as an addition problem with the same value. We just have to be really mindful of what's happening when we do that. So let's go back to our problem. The rest of it says your task is to work with your team to develop a convincing argument to answer this question. You may use examples from the list below or make up your own. So most students, I'll be honest with you, they used this one and this one in class. I'm not going to go with those just for that reason. I'm going to go with one that's a little more fun for me. I'm not going to do the fractions personally or the decimals, even though I think they'd be more fun, but I don't want to put any more confusion in there if I need to, if it's not necessary. So, but I am going to go with this guy and with that guy, because I think it's different enough to be a little challenging for us, but not so out of the box that it's even more confusing. So that's what we're going to do. So on my paper, I'm going to write, for my example number 1 is 0, take away 5. And then my other one was 0 plus -5. Okay? So going back, let's make sure we understand exactly what we are supposed to do. We're supposed to develop a convincing argument. So if I was going to argue what it would be with this, that they're the same value, I'm either going to use a diagram or words. In this case with these, I'm going to use integer tiles. I could use a number line as well, but I'm going to show why these two have the same value. So the first thing that I'm going to do is I'm going to look at the expression. So we have 0, take away +5. So 0 removing +5. I don't have +5 to take away from 0. So what I need to do is I need to add 0 pairs until I do have enough to take away. So I have 0 plus 0 plus 0 plus 0 plus 0. Now I have +5 to take away. So I'm going to go ahead and circle those and show that I'm removing them. And I'm left with 1, 2, 3, 4, 5, but not just 5, but -5. So let's go over here and let's make sure that we get the same value. So I start with 0, and then I'm going to add -5. I'm going to go ahead and start with a 0. Some might argue that's not necessary, but I really want to be able to see what I got going on. So now I'm going to add -5 to it. So there's 1, 2, 3, 4, 5, and all of those are negative. So I'm going to go ahead and make a 0 pair like this so that I can remove it to simplify it. And I end up with 1, 2, 3, 4, 5, but not just any 5, -5. So again, with this helps me to show that I will get the same answer as long as I have the same 2 digits, but we have where we have subtraction, and then we're adding the opposite. So in this case, we have subtraction, and I'm adding the opposite. The opposite of -2 is +2. Okay?